Successful hotel managers must have personality characteristics often thought as feminine, such as compassionate, as well as those often thought of as masculine, such as forceful. The BEM-6 Role Inventory (BSRI) is a personality test that gives separate ratings for female and male stereotypes, both on a scale of 1 to 7. The average BSRI score for the general male population is 5.19 with a standard deviation of 0.78. 5.19 is the average score of the general male population, so it is a parameter, and since it's the average or the mean, we would write mu equals 5.19. It is the parameter. It describes the population, in this case the male population, with a standard deviation of 0.78, and so this is the standard deviation of the population, which is sigma. Sigma equals 0.78. Both of these numbers describe the male population. A researcher suspects that hotel managers on the average differ significantly in femininity score from men in general. She conducted a survey to 148 male general managers of 3-star and 4-star hotels and found that the mean BSRI femininity score is 5.29. This 148 is the sample size, so n equals 148. And from these 148 male general managers, they computed the BSRI score, and they found that the average or the mean X bar, because it describes the sample of 148 male general managers, X bar equals 5.29. Now, perform the hypothesis testing to determine if the researcher is right in her speculation, then construct the confidence interval to confirm the result. Remember that the male population, has an average BSRI score of 5.19, and from the sample of the male general managers, they computed the average is 5.29. This number 5.29 from the sample is more than 5.19 from the population. However, we cannot conclude that the score for this sample is higher than the population score. Even though it is, statistically, we cannot conclude that because of the sampling variability. And that is why we need to perform the hypothesis test to determine if the researcher is right. But what is the researcher claim? What is the initial or the original claim? The original claim is that she suspects that hotel managers on average differ, only claim that the score differ. And so the claim is that mu is differ. Differ is not equal to. The researcher does not claim whether the hotel managers on average has a greater or less. It just differ. We don't know whether it's greater or less than, but what we know is that it differ. And the claim is a claim about the population, so we cannot use 5.29. This is the number that describes the population, the average BSRI score. So mu not equal to 5.19. This is also the known value mu naught. To write the null and the alternative hypothesis, we translate this initial claim in symbolic form, which we did, and we write the opposites of this claim. The opposite of not equals is equals, so mu equals 5.19. From the two statements, the one without the equal sign is the alternative hypothesis, and so the alternative hypothesis is mu not equal to 5.19, And the no is a similar statement with the equal sign. Next, this is the hypothesis test for the mean. So the question is sigma known or sigma unknown? Is the standard deviation of the population known? In this case, it is known. And it is known, we're going to use the z-test. And so we will compute the z-test statistics. In this case, the sample size is 148, so the condition for normality checked out is met. And so we can safely conduct the test. We compute the test statistics. This test statistic is the z. Test statistic equals x bar minus mu naught over sigma divided by the square root of n. X bar is 5.29 minus mu naught is 5.19 over sigma is 0.78 divided by the square root n is 148. Put this in a calculator, we will get 1.55968, which we rounded to 1.56 to 2 decimal places. Next, we compute the p-value. To compute the p-value, we need to determine whether this is the two-tailed or one-tailed test. Because of the not equal to sign in the alternative hypothesis, this is not just the left, the right, but the two-tailed test. We don't know which one yet, but the p-value is the probability, the area of these two. Since the numerical value for the test statistic is positive, we label the right tail. And so this number on the right is 1.56. The area of this is the probability that z is greater than 1.56. And this is 0.0594 using either a calculator or a z-table. And so the p-value is twice this area, 2 times 0.0594, which is 0.118. We then compare this p-value to the significance level alpha, but alpha is not given, so we will use the standard alpha 0.05. 0.118, the p-value is greater than alpha, and so the p-value is large. And if the p-value is large, we would fail to reject the null hypothesis. The conclusion is about the null hypothesis here, so we fail to reject the null hypothesis. Now, if we fail to reject the null hypothesis, then we would support it. But if we support the null hypothesis, then we would have to reject the alternative hypothesis. But the alternative hypothesis is the initial claim. The initial claim is that whether the score differs, and so the initial claim is the alternative hypothesis. We conclude the test by writing a statement. The question is that, is the initial claim includes the equality? And in this case, no, it does not include the equal sign. And since we fail to reject the null hypothesis when the initial claim does not have the equal sign, the statement that we will need to write is that there is not sufficient sample evidence to support the claim that the average BSRI score of hotel managers differ from men in general. Lastly, we will construct the confidence interval to confirm the result. To construct the confidence interval, we would need to compute x bar plus or minus the critical value z star times sigma, because sigma is known, divided by the square root of n. And so this is the sample mean plus or minus the error. The sample mean is 5.29. plus or minus the z-score for the 95% confident level. We use the 95 confidence level because the significance level is 0.05. The confidence level is 1 minus alpha. 1 minus 0.05 is 0.95. The corresponding critical value for 95% confidence level is 1.96. Sigma is 0.78 divided by the square root of n. N is 148. This is 5.29 plus or minus 0.126. If we take 5.29 minus 0.126, we will get 5.164. And if we take 5.29 plus 0.126, we'll get 5.416. We are 95% confident that the true unknown mean score is between 5.164 and 5.416. The null value is not mu equals 5.19, is between the two values, so we cannot reject the null hypothesis. That is why we fail to reject the null hypothesis. With the confidence interval, anything that is outside of the interval is the rejection region, and anything that is within is the fail to reject. And so again, this is why we can conclude that we failed to reject the null hypothesis. And the conclusion is about the null hypothesis only.